Hello everyone. Today I'm again here with another topic of class 10 mathematics, which is coordinate geometry. Now, the coordinate geometry is also a very important topic here where we'll be discussing about some of the basics of it. Then we'll be talking about the distance formula and following it, which we'll be discussing about section formula. So, let's start with the basic definition that what is coordinate geometry and what we have studied till now in our earlier classes. So first of all, coordinate geometry. What is coordinate geometry is that it is a branch of mathematics in which geometrical problems are solved through the algebra using the system known as coordinate system. So this is what coordinate geometry is. Now what is our learning objective here is, first one will be going through quick recap of the basics which we have studied in the grade 9. Then we'll be talking about the distance formula, following which we'll discuss about section formula. So let's move to the first part, which is basics. So when it comes to basics, we know already that the x-axis is called horizontal line, y-axis is called vertical line, and the point of intersection of x-axis and y-axis is called origin, whose coordinate is 0, 0. Then also we know that when we draw x-axis and y-axis, then it divides the entire plane into 4 parts. Each part is known as quadrant. So here we have first quadrant, second quadrant, third quadrant, and fourth quadrant. And in these quadrants, we also know what will be the sign of coordinates. As we know, any point is denoted by two coordinates, that is x coordinate and y coordinate. So in the first quadrant, x will be positive as well as y will be positive. That means it will be positive, positive. In the second quadrant, x will be negative, y will be positive. That means any point in this quadrant will be of the form negative, positive. If you talk about the third quadrant, here x will be negative as well as y will be negative, and so any point in this quadrant will be of the form of negative, negative. Then if you talk about the fourth quadrant, here x will be positive and y will be negative, so any point in this quadrant will be of the form of positive, negative. And if you summarize it into the tabular form, then in the quadrant 1 we have x positive, y positive, and the point will be both positive, that is x coordinate and y coordinate. Quadrant 2, x negative, y positive, point is negative, positive. In the quadrant 3, we have x negative, y negative, point will be of the form negative, negative. And in quadrant 4, we have x positive, y negative, point will be of the form of positive, negative. Now one more thing, remember that when we talk about the quadrant Q1, Q2, Q3 and Q4, it also can be written as quadrant 1, quadrant 2, quadrant 3 and quadrant 4. And we can further also denote it in terms of letters. So we can write the first quadrant as XOY. The second quadrant can be written as X dash OY. Third quadrant can be written as X dash OY dash. And fourth quadrant can be written as XOY dash. So rather than writing Q1, Q2, Q3 and Q4, they can mention in this way also. Moving to the next part, where we'll talk about a point. So when you plot a point, in that case, we know that if you talk about a point, it will have two coordinates, x coordinate and y coordinate. So here, if I'll talk about x value, that means x coordinate of the point P, that is distance of the point P from y-axis, and this is a perpendicular distance. So we can say it is a perpendicular distance of the point P from y-axis. If you talk about y, that is perpendicular distance of the point P from x-axis. Remember, distance is always positive, so we are not going to take minus sign with it, but coordinates can be positive, negative, or 0. Then also we need to remember that any point on x-axis will be of the form a comma 0, and any point on y-axis will be of the form 0 comma b. That means on x-axis y coordinate will be 0. Here y equals to 0, and on y-axis x coordinate will be 0. That point needs to be remembered. And we already know the coordinate of origin is 0 comma 0. Next, one more thing we need to remember, that x coordinate is known as abscissa and y coordinate is also known as ordinate. So these are the few points which we need to remember before we go ahead with the discussion of distance formula and section formula. Let's talk about distance formula. So distance formula is used to find the distance between any 2 points in the coordinate system whose coordinates are given. So the distance between any 2 points P x1, y1 and Q x2, y2 is denoted by PQ and is defined by PQ equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square, which also can be written as square root of x1 minus x2 whole square plus y1 minus y2 whole square, as we know that a minus b whole square is same as b minus a whole square. Now the same formula also can be written as PQ equals to square root of difference of abscissa whole square plus difference of ordinate whole square. So that also can be written, because as you know, it doesn't matter whether we write x1 minus x2 or x2 minus x1, so we can just say is a difference of abscissa and difference of ordinate. Now moving forward, we'll just see that how we can prove it. So in order to prove this, what we are going to do, we are going to draw perpendicular from P and Q to the x-axis, let it be A and B, and we'll also draw perpendicular from P to the line QB, which we'll write it as C. Now here, what will happen is the value of OA is x1 and the value of OB is x2, which means the value of AB will be x2 minus x1, and which will be also the value of PC, as here ABCP is a rectangle, and so their opposite sides will be equal. Also, we can see here that PA will be equals to y1 and QB will be equals to y2. That means QC will be equals to y2 minus y1, and in this case, as we know here, that this is y1, this will also be y1. Now, in triangle PCQ, if we use Pythagoras theorem, we can write PQ square equals to PC square plus QC square, which can be written as x2 minus x1 whole square plus y2 minus y1 whole square, and so PQ will be equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Remember, here we are not taking minus sign when we are taking a square to square root, because distance will not be negative. So we'll have the value of PQ as square root of difference of x coordinate whole square plus difference of y coordinate whole square. Next, we'll see some geometrical application of distance formula, where we'll see first about the collinear points, then we'll be seeing about the triangle, and then quadrilateral. So starting with the collinear points, three or more points are said to be collinear if they lie on the same line. So we can write three or more points are said to be collinear if they lie on the same line. That means if I will take three points, suppose I can take in this form where it will be AB and C will be somewhere lying in between AB, or we can have A, B, C, or we can have B, C, and A. So these are the three different situations where the point can be arranged, and from this we can see if these points are collinear, what will happen is AC plus BC will be equals to AB, or we can write AB plus BC equals to AC, or we can say that AB plus AC equals to BC. So we have to prove that the 3 points are collinear. What we'll do is we'll find the distance between each two pair of points, and then we'll see that if the sum of any two length is equals to the third. If it is, then we can say points are collinear, otherwise it will not be collinear. Next is triangle. When it comes to triangle, we have different types of triangle. So let ABC are the vertices of a triangle whose coordinates are x1, y1, x2, y2, and x3, y3. Now, in order to prove that what type of triangle it is, again we are going to find the distance between each 2 points, and then we'll see how we can use the distance formula to find what type of triangle it is. So first one, we can say that if all sides are equal, that means if AB equals to BC equals to AC, we can say that then the triangle is equilateral triangle. Second, if any two sides are equal and points are not collinear, then the triangle is isosceles triangle. Third case, if any two sides are equal and satisfies Pythagoras theorem, then the triangle is right angled isosceles triangle. If in this case here none of the two sides are equal, that means if AB is not equal to BC is not equal to AC, then the triangle is a scalene triangle. If it satisfies Pythagoras theorem, then the triangle is right angled triangle. So these are the different ways by which we can find out that which type of triangle we have. Moving to the quadrilateral part, if suppose we have been given four vertices whose coordinates are x1, y1, x2, y2, x3, y3 and x4, y4, and we have to find out what type of quadrilateral it is. So mainly here it will be four types where we will be talking about parallelogram, rectangle, rhombus and square. So let's talk about first that if we have opposite sides equal, that means AB equals to CD, BC equals to AD, and if diagonals AC is not equal to BD, then the quadrilateral is parallelogram. Second, if suppose we have opposite sides equal as well as diagonals also equal, then we can say the quadrilateral is rectangle. Third is if we'll say all sides are equal, that is AB equals to BC equals to CD equals to DA, and diagonals are not equal, we can say that it is rhombus. And next, if we have all sides equal as well as diagonals are also equal, we can say it is square. And this is how we are going to prove what type of quadrilateral it is